Okay. Hi, everyone. I'm Danelle Au, VP of Product and Solutions Marketing at Infoblox. And joining me is Cricket Liu, Infoblox's chief evangelist and co-author of the very classic DNS and BIND. Hi, Cricket.
Hi, Danelle. How are you?
Good. Cricket, you've advised thousands of enterprises on building DNS that's fast, secure, and most importantly, boringly reliable, I would think.
Yeah, over the years. Yep.
And this week, I think we were all reminded of how important DNS is. Obviously, a cloud provider had an outage that was DNS related. Last year, as part of the CrowdStrike outage, many organizations also experienced DNS failures because their DNS solution is running on the same server as Microsoft Active Directory. So let's talk about the saying, it's always DNS. And why is that?
Well, I think it's not always DNS. For example, the CrowdStrike outage was actually caused by a problem with CrowdStrike's code, and that affected a lot of Windows servers around the world, and a lot of Windows servers run the Windows DNS server, and so lots and lots and lots of Windows DNS servers were sort of down for the count. In this case, it looks like it really was a DNS outage. There was a particular domain name that pointed to a database service that wasn't resolvable, and that meant that many of this particular cloud provider's customers couldn't get to their database service. And in fact, some of the cloud provider's own internal services used the database service, and you couldn't get to them either. So you might have had a hard time, for example, opening a ticket. So that was a big deal. We've seen this for a long time. Way back in 2016, I think it was, we saw the big Dyn outage, DYN.
That's right. That's
You
right.
remember that?
Remember that? Yeah.
Yeah, yeah, they were a big cloud or not cloud hosting provider. They were a DNS hosting provider based in Manchester, New Hampshire, and run with some people I knew quite well. And they were taken down by a withering DDoS attack, the largest I think that we'd seen up until that point. And what sort of stunned everyone was how much market presence they had at the time, because for the duration that they were under that DDoS attack, you couldn't get to all kinds of well-known web properties around the internet, like the New York Times and the PlayStation Network and Twitter and all kinds of other things.
Great. That's great. So you just talked about some of the ways DNS can fail, right? One, which is a DDoS attack. You know, you can't resolve to that specific domain. Either maybe somebody fat fingered an IP address or some other reason. Can you just maybe walk through all the various ways that DNS can fail?
Sure. I mean, there are lots and lots of possibilities. Like you said, there's authoritative DNS servers being DDoSed. That's what happened in Dyn's case. Misconfiguration, maybe somebody enters something incorrectly. In the case of this particular cloud provider that happened this week, I would imagine that everything they have is automated. So they've been very tight-lipped about what actually happened. It's hard for us to know. Sometimes it's a misconfiguration of the DNS server itself. So for example, if you introduce an error on the DNS server that's giving out these responses, you can cause those authoritative DNS servers to send non-authoritative responses. And then recursive DNS servers that are out there on the internet and find their way to these authoritative DNS servers, when they see that the answer is non-authoritative, they won't accept it. They'll say, oh, no, that's not a legitimate response. I expected that to be an authoritative response. Lots and lots and lots of possibilities. A lot of them, unfortunately, are self-inflicted, and a lot of them involve somebody making what might seem like a very minor mistake, but DNS servers are pretty unforgiving about how they handle those.
Great. So what's the best practice? How should organizations design for DNS resiliency?
I think that there are a number of things that folks can do. One that I think is the best practice and that I've been recommending for some time is to run a heterogeneous set of authoritative DNS servers. So these days, of course, it's very easy to sign up with a internet-based DNS hosting provider. There are lots of those. There are many of them that are very good. But if you put all of your eggs in that one basket and that provider is taken out by, for example, a DDoS attack like happened to Dyn, then you're just out of luck. You no longer have any authoritative DNS servers to respond. Back when the Dyn outage happened, I actually sort of went on a tour afterward, and one of the things that I talked about was that best practice of having, say, some of your own on-premises authoritative DNS servers supplemented by some cloud-based authoritative DNS servers. And I gave the talk in London, and a young man came up to me after I gave the talk on a break, and he said, we happen to have exactly what you recommend. We're a Dyn customer, but we also have some of our own Infoblox authoritative DNS servers, and our DNS presence is very important to us. We do a lot of trading online, or customers do trading online, and so we measure the reachability of our website on a minute-by-minute basis to make sure that folks can trade. And he said during the entire outage at Dyn, which was hours long, I think 8+ hours long, there was only one probe that they lost. There was one probe to look up
Amazing.
the domain name of their trading platform that didn't succeed. And that's because recursive DNS servers out there on the internet are pretty smart generally. And if they see that you've got, say, 4 authoritative name servers or 6 authoritative name servers, and they try querying 4 of them and they don't respond, eventually they'll get around to trying the other 2. And also they'll learn that those 2 are responding more quickly, and they'll tend to favor them in the future. So you've got this sort of built-in resiliency in DNS if you just have that heterogeneous set.
Awesome. And are there best practices or ways to test this so that you're not just, relying on an actual outage happening to go, oh, I did design this correctly?
Yeah, I mean, one of the things that folks probably ought to be doing is every time they make any non-trivial change to zone data or DNS server configuration, verify that their DNS servers are responding authoritatively, if that's what you expect them to do. You might want to have, for example, a probe running on a periodic basis to make sure that you can resolve all of your important domain names. Run them out there from across the internet, or run them from a distant part of your own network, just to make sure that you can still resolve those domain names and that your services are still accessible to your clientele.
Awesome. What about, are there different considerations for resiliency for internal versus external DNS?
They're pretty similar, really. I think that in most cases, if you're talking about internal DNS, you're not talking about running, for example, a cloud hosting solution for your internal zones. You'll run that on your own infrastructure, but you still want to pay attention to having authoritative DNS servers sort of sprinkled around the network, right? Any critical zones should be hosted on multiple authoritative DNS servers. They should be on different subnets, in different sites, if at all possible. You want to think about locating them close to their constituencies of clients. So, for example, if you have a lot of clients that do lookups in particular zones, you want to have authoritative DNS servers for those zones that are close to those clients, so they don't have to go all the way across your internal network in order to resolve those domain names. So there are lots of things to think about there. It's mostly, I think, taking advantage of the kind of built-in resiliency that DNS has, and giving recursive DNS servers multiple authoritative DNS servers to choose from, giving your stub resolvers or DNS clients multiple recursive DNS servers to choose from. You also, if at all possible, one of the things that we recommend is using anycast, which is a great technique for allowing maybe somewhat simple-minded stub resolvers to have a single IP address or just a couple of IP addresses configured in the resolver configuration, and then have those queries from those stub resolvers routed to the closest available recursive DNS server. So we highly recommend that folks use anycast too.
Amazing. Great. Thank you so much, Cricket, for your time. I think this has been great. Really very short but very useful tips for all the folks that are dealing with DNS. Any last minute tips before we sign off?
No, I mean, I guess I would just say it's probably best to start looking at these things before there's a problem, right?
Yes.
Put in all that infrastructure, do the planning to have that heterogeneous set of external authoritative DNS servers, set up those probes and all that stuff while everything is running well. You don't want to do it when you're under the gun to figure out some sort of a problem that you're having with DNS.
That's right. All right. Thanks so much, Cricket.
Okay, you're welcome, Danelle.